Stroke, I was running up the hill. I was only 93.
Ma'am, does John understand your friend? Does John understand his chemistry background? Did you tell him about his chemistry background?
She's gonna tell you about his chemistry.
He's a chemist.
Chemist. Well, I used to be a chemist, but not anymore. But I've heard of this chemical element.
John, how long ago were you a chemist?
Well, I graduated from the university in 1943, in the middle of World War II. And if you're a male and you graduate from the University of California in 1943, you have only two choices on Monday, a rifle or a war work job. I did it that way.
Anyway, it's my pleasure to meet you. Hope to see you on your 100th birthday.
So you walk with a cane. You see, when I had this stroke, the left hand went insane. It's hopeless, you see. There used to be there's a switch that I wipe with the right finger, and I can see it and turn it right away with my right finger. If I see the switch with my left hand, my left fingers have to look for it. Even though I'm looking at the switch, my fingers have to look through it. It's too funny when your fingers are looking for something that you're looking at.
If you want to sit further in, you're welcome.
Well, you better find a place to sit down.
Right there. Tony, can you guide them over to the seat?
Yeah, you could sit right here if you'd like.
We'll move over there.
Okay.
I'm nimble.
You get a good view of John's profile. Awesome. It's worth looking at.
The doctor wanted me to use a cane. The doctor wanted me to use a cane.
It's filling up.
But if we're on the top, I only have one hand that works.
Right, it's filling up.
So if I use a cane on this hand, I don't have any hand that works.
Well, how to get started here. The time. Well, ladies and gentlemen, I want to welcome you to Griffith Observatory in the Leonard Nimoy Event Horizon Theater. Today we've got a very special event, and as you are, I'm sure, aware today, well, actually the 14th of this month was the 95th birthday of John Dobson. And John Dobson...
And it was an ordinary day.
It was an ordinary day in 1915, yes. Now, just to make sure we're all a little bit on the same page of who John Dobson is, I wanted to give a couple perspectives. I can only give my own, but I've also asked Katie Hogland, who's one of our telescope demonstrators, but who's also, since the age of, 11 or something, been an associate of John Dobson's in the Sidewalk Astronomers, which is a worldwide organization that he helped found. I'm going to give you a little bit of a perspective, maybe just from, I'll do it a little less formally here, from the viewpoint of, I built some telescopes. I got interested myself when I was about 12 years old. And there was kind of an established way of doing it. And that takes us back to, well, let's go back a century. A century ago, if you wanted a telescope, you had to be actually fairly wealthy, because the only telescopes that were built for looking at the skies were refracting telescopes. They were usually made out of very fine brass. We have an example upstairs. The very first telescope of Los Angeles is now on display. And it's a 5-inch refracting telescope that was considered a pretty big deal at the time. But really it was frustrating to a lot of people. If you wanted to look at the sky, you had to look through somebody else's, or you had to be rich. Now that started changing in the 1920s. fellow named Russell W. Porter started, well, he and Albert Ingalls, who was the editor of Scientific American magazine, kind of collaborated on articles that fired up people across the country. People mainly who were machinists or worked with materials. Porter pointed out it was both fun and easy actually to build your own telescope. So instead of spending thousands of dollars on some fairly small instrument, you could make something, a reflecting telescope, much bigger. And basically it was a fun hobby, and the article had appeared in 1925 in Scientific American, set off a firestorm. The Springfield, Vermont amateurs were the first club to build telescopes. The second was the Los Angeles Club here, and are joining us also today. And so, you know, it was a big hobby. If you wanted a telescope, build your own. Now, when I got into it in the 1970s, it was sort of a dying hobby, though. Part of the reason was it had become kind of formal. There's a certain way to do it right. And it involved a lot of other things besides really building telescopes. You had to build testers and various things. And I think it became kind of orthodox. And if you really wanted to do it right, you had to machine mountings and counterweights and all this and that. You'd end up with a nice instrument, but unless you were rich, it was going to be a pretty small one. The other problem was, because it involved counterweights and stuff, is that it wasn't very portable. And I think as time has gone on, if you really want to look at the sky, you have to get away from the glow of the cities and stuff. So portability is important. So home-built telescopes were beginning to, you know, it wasn't such a big hobby when I got involved. The gentleman sitting over here, I think, changed people's attitudes a great deal. John Dobson, starting in the late 1960s, if I recall, or mid-60s, is that right, John? About when did you start building telescopes?
Oh, I don't remember when I started making telescopes, but the Sidewalk Astronomer started in 1967.
Okay, so around that time,
1968.
the organization you started began touring around with telescopes that you guys designed.
But I'd been making telescopes before that.
Okay, but you started with those kind of traditional books anyway, right?
I had one stupid little book. And nobody to talk to.
But what John did was actually made telescopes that were mechanically very simple, yet...
And they were made out of porthole glass.
Porthole glass, your tubes are cardboard, the mechanical heavy parts are plywood, and you end up with something, you know, like this.
I tell people if they want to make a telescope, get to California. We have all these cardboard tubes and they're already made.
So no longer was it a daunting task to actually, well, first of all, make a telescope that's a lot bigger than what people used to consider a big telescope. An 8-inch telescope.
The porthole comes up to 2 feet in diameter.
Yeah, so instead of getting the finely cured Pyrex glass that just like Palomar had, that maybe you could get 6 inches or 8 inches for your beginning telescope, John found by using porthole glass, which is 4 times the area of that kind of stuff, that you could build telescopes that were huge but didn't cost very much. And also just your attitude towards the mechanical side of it. You build the telescope with the optics, so you're not stuck with a beautiful mirror with no place to go, which is really what happens with at least used to happen a lot with amateur mirrors. You build a mirror, but you didn't know how to build the mechanical part, so you built a mirror. But I think his type really encouraged a lot more finished telescopes. And I know the only kind of telescope I ever finished out of maybe 4 or 5 mirrors that I've made was a Dobson design. Okay.
Well, we made a 24, the mirror was 24.5 inches across, and the whole telescope weighs 600 pounds. and we've hauled it for more than 80,000 miles, and it's too late to tell me it's not portable.
That's right. So I just also wanted to mention that in the orthodoxy that sort of existed in telescope making in, say, the early 70s, Sky and Telescope magazine, which is still the preeminent sort of amateur journal, I guess they must have gotten a stack of papers from John Dobson describing the great success he had with this new way of building telescopes simply that would encourage people to do it. But if you look at this letter at all, you see that they weren't at all interested because obviously it was impossible to make a telescope by shortcutting all the orthodoxy that had been established. And but what's interesting in the same book where I found that letter reproduced, there's also all of these awards that shortly followed from all of the amateur organizations around the country. You know, the highest awards awarded to telescope builders, and you know, I mean, this is just to give you a flavor of some of the things John has done. Some of John's methods have been written up. I guess he collaborated in a book called "How and Why to Make a User-Friendly Sidewalk Telescope," which is, by the way, the covers are plywood. Very interesting little book. And now people build telescopes. You know, based on the inspiration of these original designs, but now people build up to 30-inch telescopes or so that fit into compact cars. And really, this whole enthusiasm and giant size of telescope is really thanks to John Dobson, who's sitting right beside me here. Now, I'll turn it over to Katie Hogland, our telescope demonstrator.
I'd like to start by thanking John for getting me to where I am today. It was actually on his, I suppose it must have been your 82nd birthday, that I first met John up here at Griffith Observatory. He was building a telescope, much like we're doing out front today. I built a telescope, and I came up here for 10 years on the front lawn at star parties. They finally cut me a paycheck so that I'd go home. But that being said, John has definitely touched more than just my life by bringing telescopes out to the public. In a conversation I had with him just before we came on stage this afternoon, he brought up the good point that if there wasn't such a need, it wouldn't have been such a big hit. People have been looking through the Sidewalk Astronomers telescopes for 40 some odd years now, and literally millions of people have been able to see the night sky and the universe that they live in because of the efforts of John Dobson and all the rest of us who follow him. It's an amazing thing because it's so important to understand our place in this place, the universe as it stands. And by taking large aperture telescopes out to the national parks and out to street corners and everywhere in between, he's been able to get millions of people over the course of all of his followers to be interested in space, even if it's only a passing interest, to understand their place in the universe, and he's inspired countless astronomers to follow their dreams in that sense. I suppose we can open up the floor to a Q&A session. Does that sound good?
Yeah, and we'd like to invite you to, if you have any questions or if John has any stories.
I had her test the 60-incher.
Talking about the Mount Wilson one right
Yes,
about this
Mount Wilson. What's the matter with the optics on the 60-incher? She told me it has astigmatism. I had to turn my head this way because I have astigmatism already. And so I found out, no, it does have astigmatism, and it's a little high at the middle. But anyway, when she was a little kid, I had her test the tested curve on the 60-incher. That was the first important big telescope.
I wouldn't have been able to do it if he hadn't taught me how, though. John, did you have some questions for them that you want to start off with?
If they want to ask me questions, they can ask me questions. I myself am not particularly interested in telescopes. I want to know why the hell we see a universe. But at any rate, if you want to ask me a question, you can ask whatever you like. I don't have to answer.
I just wanted to know how you got involved in it. What inspired you?
I got born. What's your problem?
All right, but John, were you...
Considering all the people who are born and don't care about the universe, what drew you into a love affair with the universe?
What's that?
There were a lot of other people who were born who don't care as much about the universe as you do. What sets you apart? Why are you as interested in the universe as you are?
Well, I don't know. I think I have a bad habit of looking at problems that other people don't look at. Like, why does the cat eat a little bit at a time? And if a dog finds the cat bowl, he cleans it up. Well, there's a reason for this. Cats are descended from mouse eaters. They get a little bit at a time. Dogs are descended from wolves. They eat a deer once on a Wednesday. And if you don't eat all you can hold, you may not make it till next Wednesday. Well, anyway. I have to worry about why we see a universe at all. But you don't have to ask me about that. That would take another day or two.
Yeah, I'm curious to know what sparked your interest. Like, what made you like want to explore the universe? Like, what did you get into it?
Can you translate all that? I can't hear him.
John, the people want to know.
What sparked your interest?
What sparked your interest? What?
I think just getting born in China sparked my interest.
Can you tell us a little bit about what your early life in China was like?
Well, more people know what China is like than people who know what the United States is like.
You make a valid point. All right. Why did you build your first telescope?
So I could see something.
What did you want to see?
I wanted to see what the heck's going on out there. And we had a porthole glass, you see. Somebody gave us a porthole glass. And so we made it, I think it was a 12.5 incher. And so we made it that way. Do you know why the size is 12.5 and 18.5 and 16.5 and 24.5? Do you know how come?
No.
If you put a 16-inch glass in a 16-inch hole, it goes straight out to sea.
And what became of your first telescope? What happened to the 12.5 incher that you built?
One of the first telescopes that we made is in the bay.
How to get there?
Well, somebody didn't like it and threw it in the bay.
John, why are you allergic to the Big Bang model?
Because it's so bad.
Can you tell us more about
It's not my fault.
What's the difference between your model and that model?
Well, everything. But I'll give you the observational evidence on my model as opposed to the Big Bang model.
Okay.
The Hubble telescope reports that there is more than enough hydrogen in the intergalactic voids to make all the known galaxies. Now, there's no way that the Big Bang model could have enough hydrogen left over to do it all over again. But I have the stuff recycling from the border. And I think the evidence that it's recycling from the border is that there's more than enough hydrogen lying around loose to make all the galaxies we know about.
Do you have any more questions? Yes.
So, John, how do you see the universe?
I just look around.
Yes.
John, tell us the story about the time when you were out showing people how to look through the telescopes and what they could see, and other people would walk by and they thought that you were holding onto a cannon or something.
Did you hear the
They
question?
thought it was a weapon.
20 years ago, I could have heard what you said, but not anymore.
I will summarize as best as I can.
Go ahead.
There is a story floating about that you were one time showing people things through the telescope, but somebody mistook it for a cannon.
Oh, yes. One time we had a 6-incher on the sidewalk in San Francisco, on Haight Street, actually. And the cops came and shook everybody down. And I said, "What's the matter?" He says, "There's a report of a gun on this corner." Well, it was a 6-incher. It would have taken out a city block.
Are there any other funny stories like that?
There are a lot of stories like that.
John, I've heard you had a good story about a park sign. It was, maybe Katie, you know what I mean,
The National Park Shield. Can you give us the saga of the National Park Shield that you were given that they almost took from you?
Oh, I don't remember that.
Okay, well then we'll spare you.
I should tell you though, when we first took the 24-incher up to Glacier Point in Yosemite, we set it up on the ground, and then the security ranger saw it. He says, "You'll have to take it down before dark." However, my friend was smart. He takes the ranger over there where we can make a phone call down to the rangers on the floor of the valley. We are staying. But that 24-incher has spent more than 100 nights at Glacier Point in Yosemite. That's 7,000 feet. And there are a lot of people that have looked through it up there. And I've been told by 4 professional astronomers they never had a better show through any telescope than through that 24-incher. Wow. It has a nice tall ladder, and the ladder has outriggers. You set the ladder up, plant the back feet, plant the front feet, then you toss the outriggers out. And as soon as they hit the ground, you got poles going from 1/3 of the way down from the top, right down to the ground. And it will not go sideways.
Yeah, yeah.
It's the best ladder I've ever been up.
Looks like we have a question up here.
I've been to Glacier Point every year for as long as I could remember, and I had never seen that telescope.
What's that?
She's been to Glacier Point every year for as long as she can remember, and she never saw you there. Where else might you have been?
Well, that's because you didn't go early enough. I'm probably older than you are.
Why do you do this, John? Why do you do this?
Well, because everybody else needs to look through the telescopes. I didn't do that part. But if you want to see if you want to see what the universe looks like, our eyes are not good enough to do that by themselves. So we need optical help, and it's called telescopes. And so the sidewalk astronomers simply help other people look through telescopes. We've already looked through telescopes ourselves, but we go out of our way to make it possible for other people to look through telescopes also.
Did you ever see a woman that could see the moons of Mars without a telescope?
Oh yeah, sure. This was at Glacier Point. We had the telescope that's out on the ground, the one called the little one,
Jupiter,
the 18-incher. We had that telescope there. And she wanted to know, well, we were looking at Saturn. And I asked her, can you see? So, well, no, she wanted to know something about Saturn.
Jupiter.
Anyway, so she wanted to know whether you could tell just by looking at it that it's Saturn. Anyway, through the telescope, there's no trouble telling you whether it's Saturn or not. But she wanted to know what it looks like with her bare eyes. So I asked her to go out past the building where Jupiter shows and see if she can see anything near it. She wants to know how good her eyes are. She wants to know whether she sees any, so I asked her whether she sees anything near Jupiter. Oh yes, she sees the things next to Jupiter. How far away are them? She measures it for me with her thumb and finger. She can see the moons separately, 1 and 2 and 3, and she can measure the distances. Don't tell me she can't see it. I know several people who can see. I've known several people who can see the moons of Jupiter with their bare eyes. It's not that difficult. Not that difficult. But you may not have tried it.
John, is the 24-inch scope the biggest one you've ever built?
It's the biggest one we've run around the place, yes.
Do you have any
But we've hauled it more than 80,000 miles. It's done a lot of public service. It's set up now in a different way, and we can't use it anymore like that. And I'm very sorry about that. I am dreadfully sorry about that. I wish we could still run the 24 like we used to run it through the national parks. But let me tell you an interesting thing. We sidewalk astronomers always had this problem: how to get telescopes in the national parks. The national parks is where the American public and the rest of the public goes to see what the universe looks like. And so I was at Bryce Canyon, and they had a three-night star party. They have this great big parking lot, and they must have had more than 50 telescopes on this parking lot, and nobody's allowed out there until 9 o'clock at night. There's a lecture from 8 to 9, and at the end of the lecture, 300 or 400 people come flooding out all over through all these telescopes, you see. And so they've got this problem solved, how to get telescopes in the national parks. Leave the telescopes with the kids. Get the kids to the park. Anyway, this was always a problem with us sidewalk astronomers. How can we get telescopes in the national parks? Anyway, they've got the problem solved. They have 3 nights star parties, 3-night public star parties, and it was first class. It really was first class.
Grand Canyon has a seven night in a row.
What?
Grand Canyon in June, 7 nights in a row, public star party every year. Grand Canyon.
Well, they don't do it as well as that one was done.
I'm curious to know, like in all your years, John, of looking through the scopes, have you ever seen anything else besides planets and stars and gases and stuff, or meteorites?
What's all this?
John, he's wondering if you've ever seen anything that isn't a star, a planet, or a meteorite, or something like that. Have you seen anything
Oh yes,
unusual
people want to know whether it's real or not. So I let them look through a window. They know that the cannon is on at 9. Then it's real. Then they want to look. When they find out that we're not pulling the wool over their eyes, they find out that the wool is on my eyes. Then they want to look.
Do you think you've changed the world?
What?
Do you think you've changed the world?
No, but the world's changed me.
Do you think the world thinks it's been changed because of you?
Do you think the world thinks that it's been changed because of you?
That the world, what?
Do you think that the rest of the world thinks that it's been changed because of you?
Oh, I don't know, probably.
To add on to that, actually, again, as I was speaking to him before we came in here, he was talking about the list of birthday wishes that he's received from across the globe. John, will you show them how long that list was?
How many? How long? What?
The list of your birthday greetings that Donna was reading you the other day. How long was the list? You showed me earlier.
Oh, oh Lord, they're from all over the world. Anyway, it was high time that somebody took telescopes for the public, and I'm just happy it was us. Somebody had to do it, and somebody would have done it if I hadn't been born. But I did get born. So it's too bad for the other guy.
John, why is it important to you that people look through telescopes?
I don't know. If it's not important to you, well, that's your problem. But I have my problem. It is important to me.
But why is it important to you?
I don't know why. You know, why questions are very difficult to answer. I'll give you an example.
Okay.
The physicists know how things fall, not why they fall. They know how things coast, not why they coast. They know how things behave because they're electrical. They have no idea why they're electrical.
So I'll ask you differently. What do you hope people get out of the experience of looking through a telescope?
What's that?
What do you hope that people will get out of the experience of looking through a telescope?
Oh, I don't know. What people get out of it depends mostly on the people that are looking. It doesn't depend upon us. It doesn't depend upon the telescopes altogether either. It depends upon who's looking and what he's able to manage to understand from what he's seeing. And it depends a great deal on the past information that you have put in there. See, when you get new information, you compare it with the information you already have in there. And if you don't have anything in there, you're broke.
What would your advice be for any young 5-year-old fellow?
What's that?
What would your advice be for a 5-year-old?
For a 5-year-old? Grow up.
Yes.
How has looking at the universe all these years affected your understanding of our relationship with it, or our place?
Did you hear the question?
What's that?
How has your observation of the universe changed your perspective on our place in it?
I still don't get you. Slow down.
How have all of your years of observing
Yes.
changed your perspective on our place in the universe?
On our place in the universe? Oh, I don't know. We're still kicking.
John, how do you feel when you see somebody looking at the telescope who's never seen the moon in a telescope? How do you feel?
Well, as soon as they see see the moon through a telescope, they've joined the minority. There are very few people that have seen the moon. When you consider the number of people that walk around on this planet, the number that has seen the moon through a telescope is very small.
Yes.
John, you mentioned about 20 years ago, and that's special on PBS, about you want people to see the universe, because if they don't see it, they don't think, and they don't wonder. They're as useless as not thinking, but we're talking about seeing. Do you think language today inhibits us from learning about the universe? Schools and education are failing in that respect.
What's all this? I can't understand all this.
Do you think that the way that our language is constructed and the way that our school system is constructed is inhibiting our ability to understand the universe?
Well, we have the ability to understand the universe. I don't see anything that intimidates us.
How do you think about dark skies, and what do you think about the importance of having dark skies?
Well, if you want to see what the rest of the universe looks like, you need to keep these skies dark, yes. The light has to come in from outside. And if you've got it all lit up for the light that's coming from inside, you're not going to be able to see nicely what comes from outside.
We have a question over here. Laura.
John, you mentioned that the world changed you. You didn't think you had changed the world, but the world has changed you. And I'm wondering, in what way has the world changed you?
Probably in every way that I've been changed.
Are there ways in which you feel you have battled the world and the world won?
I don't get that one.
Are there ways in which you have battled the world, but the world won?
I still don't get it,
Well,
even
okay.
from you.
Well, that's fine, because I repeated it verbatim.
It's okay.
So the 24-footer telescope was your favorite?
Our 24-incher was, I've had the best show through the 24-incher that I've had through any other telescope.
So that was your favorite out of all these scopes you ever had?
Was that your favorite telescope? Do you have a
Well,
favorite?
yes, I think I would have to say of the telescopes that I've used, that's my favorite.
Do you have a favorite of telescopes that you haven't used?
Oh, yes, the Hubble telescope.
Yes, up in the back.
Have you gotten to use like the big professional scopes before?
Have you gotten to use the big professional telescopes before?
Yes, I've looked through the 60-incher on more than one occasion.
Over at Mount Wilson.
Jupiter and Saturn look very big, very bright, and very fuzzy. If you want to see what they look like, get down on the sidewalk with us.
See in the front row here.
Do you have any goals that you still wish to achieve at this point in your life?
I'd like to see more national parks do what Bryce did. Leave the telescopes with the kids and get the kids to the park.
Why?
So that the people can see other things from the national parks besides trees.
Did you actually know that the National Park System has established an astronomy program and now has a director in charge of that program?
Well, I don't know about it. I don't know. But the national parks are the places where the American public and a lot of other publics also come to see what the universe looks like. That's where they get to see the sky. And if there are telescopes there, they get to see the sky a lot better than they did without them.
John, hi.
Hi.
Recently, you were talking about how the chloroplasts.
How the what?
Chloroplasts?
Chloroplasts,
were
yes.
running the show?
We live in a planet with an oxidizing atmosphere in a universe of hydrogen atmosphere, which is certainly not oxidizing. And we owe it all to the chloroplasts. The chloroplasts have their own genetic programming. They're not part of the tree. They're not part of your spinach. They have their own genetic programmings, and they make our food for us and dump oxygen out as waste. And they've left us with a whole planet of with an oxidizing atmosphere. And almost nobody feels that he owes it to them. I had at least recognized my debt.
John, what does it do to your perspective when you look through a telescope and you see objects that are, say, a couple of million light years away, so the light left a couple million years ago, and you see something else where the light left a few hundred years ago, and so forth? What does that do to your perspective of the view of the universe?
Well, you can see that there are things a lot farther away than downtown.
And we don't see it now.
Yes, you can see it now. Yeah. It happened then, but you can see it now. You see, in 1905, Einstein noticed that space and time are a pair of opposites. If you see something 1 light year away, you see it 1 year ago. And the away comes in squared with the plus sign, and the ago comes in squared with the minus sign, and they're both equal, and the total goes to 0. You see, the universe isn't made out of space and time. It's not made out of forces. For every momentum, there's an opposite momentum. For every angular momentum, there's an opposite angular momentum. And the same thing for space and time. Everything you have seen away from you in space, you have seen in the past. And the time ago comes in squared with the minus sign, and the distance away comes in squared with the plus sign, and it's always been equal. And the total has always been 0. Now this is way back, this is new in 1905. It's not new now.
John, what is the most beautiful thing you've ever seen?
The universe.
A little more specific? Anything specifically?
Well, I think the moon is very charming. And let me ask you a question. Why is the full moon 9 times brighter than a quarter moon?
Does it have to do with the angular reflection of the surface?
Has to do with what?
The angular reflection of the surface.
It has to do with the fact that the moon is covered with glass beads. Any 4th grader could have figured this out. Only one astronomer in the history of astronomy figured that the moon is going to be covered with glass beads. the moon gets hit with these great big things, you see, and the explosion is much harder than is necessary to vaporize the rocks. Now, the moon doesn't have any atmosphere, so the stone vapor condenses to spherical glass beads. Now, spherical glass beads shine back the light from the sun toward the sun. So when the moon is full, we see the glass beads on the moon shining back toward the sun, and we're on the sun's side, so we see that light. Now you can see the long glass bead streamers from the crater Tycho. They would reach from Los Angeles to Denver. They're great, big, long glass bead streamers. And you see them when the moon is full. You don't see them when the moon is quarter, you jerk. You see them when the moon is full. And also, they're glass beads orbiting the sun. So if you look right down the Earth's shadow through the night sky, if you look right down the Earth's shadow through the night sky, you see the glass beads orbiting the sun shining back at you. That's called the Gegenschein. Gegen is German for against.
Do you regret that you have not traveled to the moon? Would you like to go there?
I dreamed one time that they're going to take me to the moon. What a lovely dream. But they're not going to take me to the moon. There's no danger of that. I can hardly walk here.
John, what are some of the other things that you like people to think about when they're looking at the moon, if they stay late enough tonight to look at the moon through the telescope? What are some of the other things you'd like them to notice about it?
Well, there are a lot of things I like to have people notice about it. But I have to tell you a story. In San Francisco, I've been getting out a 9.5 incher about 3 miles from the beach. And we were looking at the moon. It was a little fatter than first quarter. We were looking at the moon. And this lady looks through it. She says, "What's shining on it?" I thought people knew what shines on the moon. It never crossed my mind that that's a problem. What's shining on it?
Did you tell her? Do you think we should go back to the moon?
Oh, I don't object to that. But we had the telescopes in New Arrivie. That's the capital city of the Hopi Reservation. And it rained. We had to wrap the 24-incher all up. And when the rain was over, we had a full moon on the last night, which was all clear. And I mentioned to those Indian girls that the moon is covered with glass beads, and that 1/3 of the surface material on the moon is glass. And one of those girls asked me, "How do you know that?" Well, I said, when they came back, they brought that stuff from the moon. Someone went there. Someone went there. I'm quoting.
Try one more time, John. What should we look for tonight?
Whatever you can see.
Well, what do we see with those big black splotches on the moon? What's that all about?
Well, I often have people who have looked through the telescope at the moon. I have them look again. You see those 3 big, dark, smooth areas in a row? The middle one is the Sea of Tranquility. That's where the first footprints are. And they'll be there for 1 million years. Well, we don't know that it won't get hit by an asteroid between now and then. But at any rate. And so I tell them, the Sea of Tranquility is as big as Oregon. If you had a picture of Oregon as big as that, could you see Portland? Well, never mind the footprints.
What are they? What are these big black seas?
They're great. They're places where the moon got hit by an asteroid, and the lava that came out was mantle lava. That's why they're dark. That's mantle lava. It's the same here. Same on our planet. When we get asteroid impacts that go all the way down to the mantle, like Hawaii. The Hawaiian Islands started way up near Bering Straits, and all the way down through the mountain of these, all the way down through the ocean of these little mountain tops. And there's another mountain coming up south of the Hawaiian Islands now. I understand that's going to be taller than the one that we have now.
Are you saying an asteroid poked a hole through the Earth and created...
No, not a hole. Absolutely not a hole through the Earth.
No, but what, through the mantle, I mean, the crust. What?
Through the crust, yes.
And that's what is still causing that magma to arise?
That's the lava come out, the mantle lava come out, yeah.
How did you feel the first time you looked through a scope, like emotion-wise? Like, how did you feel?
How did you feel the first time you looked through a telescope?
Oh, I don't remember. That's too long ago.
Do you remember what it was? What was the first thing you saw through a telescope?
Well, my dad had one of those stupid refractors in China. We used it way back then. Oh, I have to tell you a story. There was a friend of mine in Hollywood who had to move from one house to another. And she had one of these brass refractors, you see. And she wanted to know what to do with it. I said, it's unkind to give it to anybody. She threw it in the dumpster. It's unkind to give it to anybody.
Yes.
John, do you think the moon was part of the Earth at one time?
The standard model is that we were hit by something nearly as big as Mars, and the stuff that was splashed off the Earth accumulated into the moon, yeah. But I'm not that old.
Have you ever seen something of life in the universe, like unidentified flying objects? Do you understand?
What's he asking?
Have you ever seen a UFO?
To me, the only plane I know is the 740. There's only one plane whose sound I used to know. All the rest are UFOs, unidentified flying objects.
Do you believe in aliens?
Do I what?
Do you believe an alien exists?
I'm an alien. 我说北京的话你懂不懂?
What are aliens?
What?
What are aliens?
Well, I don't know what you mean by that word, but I know what I mean by it.
In all your years of looking through a scope, you've never seen any other life form besides a human being?
Oh, I've seen even rats and mice.
Well, what's the probability of life on other planets?
We haven't been near any other planet to find out whether there's anybody talking English.
But statistically, what would you say?
What?
Statistically, do you have a probability of life on other planets?
Well, it might be so, you see. But we're descended from fish. And if you want to talk to them, you want to be sure they're descended from fish.
Yes, that's my question. Alistair Hardy, Elaine Morgan, water babies. Evolution of us in water.
Well, we used to be fish. That's a little before my time.
Do you think there's other intelligence in the universe?
I have enough trouble here.
A lot of people we're all asking you questions about astronomy because that's where you've made such an enormous contribution. But you've also lived almost a century. And I'm wondering about your perspective, I guess, gosh, if I have to say 95 years ago, that would be 1905?
1915.
15, sorry.
Yeah, I made that mistake earlier,
my
too.
mother. Anyway, you know, what stands out in your memory looking back as both some of the most wonderful news, wonderful event you can remember, and also the most daunting or frightening or thing that made you saddest? Looking back over your 95
Lord,
years.
I don't think I can answer that one.
Okay.
That would be too difficult.
Are there a few events that stand out?
But one thing that I do notice is that this country, when it was born, stood for something which we don't stand for now.
What is that?
We stood for, well, you know what we stood for in 1776. I have to tell you one thing. When I went to England, they first regarded me as a foreigner. And I said, we were English people who told Parliament where to go. We were you guys. We weren't somebody else. They finally got that straight. But you see, it doesn't matter. Parliament was out of line to treat us that way. They asked for the Revolutionary War. It wasn't our fault.
Are you optimistic about the future?
It's going to happen. I was one time at one of, what's that? Oh dear. The astronomer in a wheelchair, what's his name?
Oh, Stephen Hawking.
Stephen Hawking. I was one time in a lecture by Stephen Hawking, and he was taking some questions, and somebody asked him about time travel. And he said, I'm waiting to hear from the future. What a lovely remark. If we could get into the past, the future would be into us.
John, how does Heisenberg's uncertainty principle help with the boundary of the universe problem?
Well, the electrons can't sit on the protons because of Heisenberg's uncertainty principle. And that's why we have a universe of hydrogen. Everything here is made out of hydrogen. There's nothing else going on here. The electrons are made first and the protons are made. And then the electrons can't sit down on the protons, so we have a universe of hydrogen. But you see, two electrons can play on 4 protons. 2 electrons can play on 4 protons. That's helium. 3 heliums makes carbon. 4 heliums makes oxygen. And if you get the carbon tied up with hydrogen, you have the Arabian oil. And if you get the oxygen tied up with hydrogen, you have the Pacific Ocean. These are not scarce items. But the uncertainty principle keeps the electrons from sitting on the protons, and that's why we have a universe of hydrogen. And everything else here is made out of hydrogen. You can complain all you like.
And how does that relate to the boundary of the border of the universe?
Well, the stuff recycles from the borders of the universe, and the negative entropy recycles with it. We get our negative entropy from the sun by way of the chloroplasts. But the sun gets it by the recycling of the hydrogen and the negative entropy from the border. And in Sanskrit, there are 2 words for energy. Shakti is the energy out of which the universe is made, but prana is the negative entropy which we get by eating and breathing. They're not used as synonyms.
Hey John, for those of us who want to make our own telescopes, do you have a special Dobsonian advice?
Well, see if you can find some place where there's some porthole glass. If you can get 2 pieces of porthole glass, one bigger one and one smaller one, then you can make a telescope for a reasonable fee. And if you want to grind it with sand, the fee becomes even more reasonable. 60 grit carborundum costs a lot of money. Anyway, the rough grinding has to be done first, and then the fine grinding has to be done. Then you have to pour the pitch slap, and you have to polish it with cerium oxide or something. Oh, I have to tell you a funny story. We were in Italy, and I said, we need some cerium oxide. And he came up with something that was white. I said, cerium oxide is not white. He said, in Italy, this is cerium oxide. What a jerk.
I'm going to take a chance, John. If you want to find the center of the Earth, how do you do it? How do the scientists do it?
Why should I want to find the center of the Earth?
Okay, if you wanted to, I want to. How do I find the center of the Earth? How do the scientists find the center of the Earth?
All right, I'm going to tell you guys a story. We had a 3-day conference on science and Vedanta in Michigan, and there were some physicists there, and they got on my case at the very beginning. They thought that they were sentient, and all this is insentient, you see? And it went on like this for 3 days. On the last day, we had a half day of questions from the audience, and the last question came to me. And I turned to the physicists. I said, I know, you think of yourselves as sentient, and all this is insentient. But if you really want to know where the Earth is, you hang an insentient piece of lead on an insentient piece of string. And nobody dared open his mouth. They died on the floor.
Yeah, thank you.
Do you have any regrets? Do you have anything left unfinished?
Well, almost everything is left unfinished. However, I'll tell you something. Somebody told me he just lost 40 pounds. I said, if I lost 40 pounds, they'd put the rest in a box.
Out of curiosity, what was it before looking telescope? What was it that you wanted to be before getting into telescope and stuff?
What did you want to be if not a sidewalk astronomer? What did you want to be before you wanted to be that?
I don't know. I never had a career. I completely missed the career business. When I graduated from the university, I had to have a war work job. So that's what I had. And then I joined the monastery. And then when I got out of the monastery, I was teaching in the adult schools. But I never had a career. I never had that choice to make. But when I was a kid, I thought being a forest ranger would be first class. I never did it. I was in Canada, and there was this lady there. I said, you don't have rangers here, do you? She says, no. She says, we have a naturalist to tell you what flower it is, and a warden to arrest you.
John, do you ever sing the Proton song?
No, I don't do that anymore.
Did it ever get recorded?
I don't know. Little protons and electrons, they make up all the hydrogen, little protons, and they all look just the same. Because they're all made out of hydrogen and they all look just the same. Anyway, I can't sing anymore.
You sounded good.
Yeah.
Thank you. Give us a show one time, last time.
Encore.
I'm recording.
Come on, John.
Why are protons so much heavier than electrons?
I didn't do it. The electron is wound up only against electricity. The proton is wound up against electricity, but also against gravity. And the gravitational windup is 18.36 times heavier than the electrical windup.
Well, one last question, I think, because we're moving so far into the future compared to where we started from that other people need to use the theater. So, over here.
Is there a motto or a saying that you live by, John?
What's that?
A quote?
Is there a motto or saying that you live by?
I still don't get it.
Do you have a good phrase to live by, or a motto, or something, a
motto?
catchphrase? Yeah.
Oh no, I don't have any motto, except be prepared. I used to be a Boy Scout. Be prepared.